Hey YouTube, Chris Patton here. Over the years, a lot of people ask me questions about how to control the pixels with Arduinos. And so a couple years back, I actually did some wiring diagrams. And here they are. This is an overview of a pixel control within Arduino. So if you're using Vixen lights, you can have your Vixen PC that runs off Cat5e Ethernet to your switch. From your switch, you can run that over to an Arduino Ethernet shield, the 5100. And then you also need to power that Arduino with USB 5 volts DC power. Off the Arduino itself, one of your cables will go to the ground, and it'll go to the ground on the pixel. And then the other pin will be your data pin. You can use any of these pins on the Arduino itself. This one's showing 6, for example, but you could use 22 if you needed to, or any other data pins that are on the Arduino itself. That cable will actually go to your data on the pixel itself. And then of course you have your power. Normally you can use a open frame transformer power, or you can use the closed transfer power supply, like one that powers your laptop or some other kind of device, as long as it's outputting 5 volts DC. So of course this is DC, so you have a positive and negative. Make sure you run your positive over to your pixel and your negative over to your pixel. So that's a brief overview. Here's a wiring diagram on the pixel LED's power details. So typically on the 5 volt DC pixels, you'll need to inject power every 50 LEDs. Each LED needs 50 milliamps or 0.05 amps of power. So you'll need 2.5 amps per 50 LEDs. And if you don't have enough power, the LEDs will turn yellowish when you're trying to run white to them, or they will flicker quite a bit. So this just shows you a little more details about how you do power injection. So your first 1 to 50 pixels will have power going to it. And then when you get to number 50, you just cap off the power. And then 50 to 100, you'll inject power again. So I know some people say, well, I'll inject power on the front side or on the front part of the pixels and then on the back end. And if I don't have enough power in between all those, I'll inject power in between. You can do it that way too. I just like doing it every 50 LEDs or pixels. So then the next diagram I did is for the data details. So your data will actually run all the way through your pixels. So an Arduino Mega will actually handle 240 pixels. So you can run that data all the way through the 240 pixels. Now if you have a gap in between, like pixel 20 and pixel 21, that's a long distance, like 50 feet, you might have to put what they call a null pixel in between that gap. So the data gets transferred all the way through. So anyways, here we have our Vixen PC ran off Ethernet to the switch, from the switch over to the Arduino itself, power for the Arduino. Your ground coming up on black will actually go, depending on the colors of your pixels. I know sometimes they make them red, white, and blue, or they come green, white, and red. You can actually look on the chip within the pixel itself and it'll tell you where positive, negative, and the data point is. But anyways, run your black over to your data negative, and your pin off your Arduino would actually go to the data input on the pixels. And then you just loop that through from pixel 1 to pixel 2 all the way up to 189, and then you can pass through to 190 to all the way through to 240. Alright, so here's the Arduino code I used to make the pixels work, and this was actually done by Andrew. I added a little bit of notes here and there for my own reference, but you'll need to load the fast LED library onto the Arduino, and there's some instructions here at the top for that. You also need to change the MAC address for each Arduino. If they all have the same MAC address, they won't communicate correctly across the network. So this is where you would change the IP address for the Arduino itself. And then down here at the bottom, this is where you'll actually tell it what data pin you want to use. For instance, in this code, it's going to use data pin 22. And there's one other area you might need to modify depending on your pixels. The order of the red, blue, green. So you want to run a test and make sure that when you have red, it's actually showing red, not showing green. If it's showing something different, you might need to change this. I know with a lot of the pixels that I buy, I had to change them to green, red, blue. So that is pretty much it. Any of this stuff can be found on GitHub for the coding. So it also runs a test when you power up the pixels, and it'll turn them all on red, green, blue, and then off. Programming in Vixen to make all this work. So here's some screenshots of my programming in Vixen. So I set up a streaming ACN E1.31 config, put down my IP address to that Arduino itself. And with Vixen, you're actually controlling 3 points per pixel. So you have your red, blue, and green. So you're actually going to have 720 outputs, even though you only have 240 pixels. And then on the advanced options, I just left defaulted. So that's it. Hope you enjoy what I've provided here, and if you have any questions, please ask. Thanks.